Good evening, everyone. A lot of people. So I'm saying hi, good evening, and everything to all of you at once. How you guys have been? Nostalgia? Yeah, right. Same here, same feeling. I think there are some new people as well. So those who do not know me, my name is Vinod here. And more than telling about myself, I'll just start with the class right away. Because that is going to be a long class. And I know all of you have already done the numbers. But today it will be a total marathon of all the things that you have studied so far. Voice not clear? Is the voice clear? Not clear to others as well? It's not a continuation. It is basically the marathon. So we'll be doing everything. I'll be discussing some concepts. And at the same time, I'll be solving a lot of questions. By the way, I have made a few questions which I call as mind benders. So it's echoing. Is the voice fine now? The fine is the voice is fine, I believe. All right. Sat Shri Akal. Good to set expectations. We just said that. So I have been told that you guys already done numbers, but I'm taking it not very slow, in a moderate speed, and depending on how you perform, we'll increase or decrease the speed accordingly. Chalo. So let's start with the first question. You might be surprised that without teaching anything, I'm starting with a question. By the way, this question is the first mind bender of today's session, mind bender 1. We have a number, and as you can see, it is of 6 digits. The first digit is 1. Then we have other digits as well, A, B, C, D, and then we have 7. When this is multiplied by 3, we get this number. This number, as you can see, the same digits are repeated, but the order has been changed. We need to find the sum of A, B, C, and D. I hope the question is clear. Simple to understand. निश्चित नो प्रॉब्लम, पहले अटेंड नहीं किया तब भी फर्क नहीं पड़ेगा, अभी सब क्लियर हो जाएगा, डोंट वरी. यश एंड चैन, जिसने कभी अटेंड नहीं किया उसके लिए भी है ये, बिकॉज आई विल बी डिस्कसिंग ईच एंड एवरी कॉन्सेप्ट व्हिच इज रेलेवेंट टू कैट एग्जाम ऑफ कोर्स. Two minutes for this. Sami has come up with answer. He says it's 19. Ankit, percentage and profit loss. Okay, that is arithmetic. We'll do that as well. But let's finish numbers for once and all. First class है राजू, कोई कुछ problem नहीं होगी. Don't worry. Just be with the flow. Okay, so let's start with this question. As we can see, 6 digits, 1, then we have A, B, C, D, and then we have 7. This has been multiplied by 3, and the new number that we get is A, B, C, D, 7, and 1. Now, by the way, can you notice one thing? That all the numbers, all the digits have shifted one place towards the left, yes or no? Can you say that? Can I say that? हर कोई शिफ्ट हो गया ना, one place towards the left, और one के आगे left space है ही नहीं तो घूम के यहाँ आ गया. That is what has happened, right? Okay, so let's try to solve this one. By the way, there's certain clues that we have. Normal multiplication हर किसी को आता है. 3 into 7 is 21, and we have 1 over here. Okay, this is solved. 3 7s are 21. 1 we have here, and 2 will be the carry forward, right? बचपन से ही करते आ रहे हैं हम लोग. Okay, 3 7s are 21. 1 2 is carry forward. Now 3 multiplied by D plus 2. 3 D's are something. 3 multiplied by D plus 2 is a number which ends at 7, right? Which ends at 7. Can we say that? 3 multiplied by D plus 2 ends at 7. That means that one, no problem. Even if you don't notice the shifting, it's okay. You can just notice this thing, right? 3 7s are 21. 1 is here. 2 goes carry forward. 3 multiplied by D plus 2 has to end in 7. That means 3D will be ending in 5. Yes or no? 3D should be ending in 5, and that is possible if and only if D is 5, right? D is 5. 3 से क्या multiply करने पे end में 5 आता है? It's 5 only. 3 5s are 15. So I'll write 5 in place of, just a minute, in place of D. So D becomes 5. 3 5s are 15 plus 2 is 17. 7 is here. 1 is the carry forward now. All right. 1 is the carry forward. ठीक है, बहुत अच्छी बात है. Coming to D. 3 into C plus 1 should end at D, which has now become 5, right? D को मैं replace कर दूँगा 5 से. 3 multiplied by C plus 1 ends at 5. That means 3C should be ending at 4, right? 3C 4 पे end कब होगा? 3 8s are 24. That means C has to be 8. So let's replace C by 8. 3 8s are 24 plus 1 is 25. 5 is here, 2 is the carry forward. हम लोगों ने C और D निकाल दिया. Coming to B now. 3 multiplied by B plus 2 should end at 8, which means 3 multiplied by B should end at 6, which is possible only when B is 2. 3 2s are 6 plus 2 is 8. This time we don't have any carry forward, right? 3 multiplied by A. 3 multiplied by A should end at 2, which is possible when A is 4. 3 4s are 12. 3 4s are 12, right? 1 is carry forward. And as you can see, 3 1s of 3 plus 1 is 4. Now all the digits have been properly accommodated. So the new number is 428571. Is it clear now? Everyone? So 4 plus 2 plus 8 plus 5. The answer is 19. Those who mark 19, well done. I'll repeat, of course. I'll repeat once. 1 A B C D 7 multiplied by 3. 3 7s are 21, but already लिखा ही हुआ है. 1 and 7 we have here, and D should be coming here, C will be here, B here, and A here. And I'll just change the ink so that there's no confusion at all. 3 7s are 21. 1 is here, 2 is the carry forward. No problem at all. 3 into D plus 2 ends at 7, right? Which means 3D should end at 5. 5 plus 2 7 होता है. कब हो सकता है? When D is nothing but 5. 3 5s are 15 plus 2 is 17. 7 यहाँ लिख दिया. 1 should be the carry forward. 3 into C plus 1 should end at 5. D 5 है. Replace D by 5. 3 into C plus 1 ends at 5. That means 3C ends at 4. It is possible if and only if C is 8. 3 8s are 24 plus 1 is 25. Replacing this with 8. 2 is the carry forward. 25 ka. 3 into B plus 2 should end at 8, which means 3B should end at 6. Let's replace B by 2. All right. 3 into what ends at 2? 3 into 4 ends at 2. 3 4s are 12. 1 is carry forward. 3 1 is 3 plus 1 is 4. And it is sorted. Okay. It's clear to all of you. Why I'm saying it is a mind bender question? Because this question opens a lot of arenas into understanding how numbers behave. Ready for that? Clear to all of you? Tell me in the comments. Be quick. Now let's do something really cool. Ready for that? Well, see, this is what being cool is all about. The charm of number 7. The charm of number 7. By the way, who was born on either 7th or 16th or 25 of any month? Your numerological number is 7, and 7 has a very strange, mysterious property. अभी ना पिछला वाला तरीका समझ में आ गया है? अभी देखो, ये भी समझ में आएगा. Look at this. 7. 7 colors, 7 notes of music, isn't it? 7 notes of music. 7 seas, 7 continents, isn't it? 7 days in a week. 7 stars in Ursa Major. है कि नहीं? 7 is all around us. The feeling of time that is in days depends on number 7. What we see depends on 7 colors. What we hear or speak depends on 7 different notes of music. There are a lot of 7 wonders of the world. A lot of things are there for 7, and today we'll do something really big about number 7. See, so whenever I divide 1 by 7, what do I get? You can check it out. You will get 0.142857 and so on. This will keep on repeating. This will never end. Isn't it? Shubhajit, that's a nice observation. iQuanta has 7 letters. 007, 7 महादेव. अब कमाल की बातें हैं. Well, so all of you can do this. आप 1 को 7 से डिवाइड करेंगे, आपके सामने ये आ जाएगा. Yes or no? आएगा? Is that right? I'll just show it to you. 1, let's put a point. 10 सबको डिवाइड करना आता है. 7 1s are 7, remainder is 3. We have a point, so यहाँ 30 एक 0 आ जाएगा. 7 4s are 28. Keep on doing it and you will get this only. Okay? It's never going to end. Cool. So what I'll write here, I'll just write all these digits. 1 4 2 8 5 7. मैंने इन लोग को वैसे लिख दिया in a clockwise fashion. No problem at all. 1 by 7 is 0.142857. Never ending sequence. Keep on repeating. That's why I put a bar over it. Well, so let's say I want to calculate 2 by 7. This can be very important in data interpretation questions, isn't it? DI में हो सकता है ना कभी कि 700 टन गेहूं उगा था इस साल, अगले साल 900 टन उग गया, तो कितना ग्रोथ हुआ है? So instead of using the calculator and doing all that stuff, you can just do this mentally. 2 by 7. So tell me everyone, the moment I put a point over here, this becomes 20. What should be the first digit after point? 0 point. 20 आ गया. पहला क्या होना चाहिए? 7 1s are 7? No. 7 2s are 14. 7 3 21. 2 से स्टार्ट होगा. जैसे ही आपने पहला डिजिट देख लिया, 2 से स्टार्ट हो रहा है, यहाँ 2 लिखो, और इस चार्ट में 2 कहाँ पे है? Where do we have 2? This is where 2 is, and we have to follow it clockwise. 2 के बाद क्या है? 8. The answer is this 0.285714. Cool enough? Interesting observation. मजेदार है. Let us try to have 3 by 7. The moment I put a point, this becomes 30. What should be the first digit after the point? The first digit after point. Hey Nasargi, how are you? 4, exactly. The moment I put a 4 over here, let's see where is 4. Oh, this is the 4. उसके बाद क्या क्या है? 2, 8, 5, 7, 1. And I got my answer. Cool enough. We can do this. Keep on doing this. 4 by 7. How beautiful is it? Put a point, becomes 40. 7 5s are 35. पहला 5 होगा. जो भी आएगा वो यहाँ पे मिलेगा हमें. Then 7 1 4 2 8. Similarly, 5 by 7. Put a point, becomes 50. 7 7s are 49. 7 1 4 2 8 5. This is a lot of fun, isn't it? 6 by 7 similarly. Put a point, becomes 60. 7 8s are 56. 8 5 7 1 4 2. And we solved everything. 7 by 7 is, needless to say, 1. So we got all the values. All right. By the way, if I move beyond this, let's say I want to calculate 9 by 7, तो क्या मिल जाएगा? 7 1s are 7 point. अब 2 बचा है तो वही चीज फिर से शुरू हो जाएगी. Is that clear, everyone? Is that clear? Chintan, because this is a recurring rational number. That is the reason, and this is an observation on which we can base a lot of questions and calculations. By the way, there's one thing why I said 7 की महिमा अपरंपार है. 22 by 7 करें एक बार. What is it? 22 by 7. 7 3s are 21. एक बच रहा है. We'll get this only. By the way, this is the ratio which changed everything for mankind. Yes or no? This ratio is known as pi. कमाल की बात है नहीं? By the way, pi is an irrational number, but 7 की महिमा ऐसी है कि उसको rationalize भी कर देता है in a way. Is that clear, everyone? The 7 is so important in our life. Perfect. So I wanted you guys to understand this. This is going to help you in some calculations, and also this will help you in falling in love with mathematics. And now the people who are scared of maths or they don't like maths, they would realize that math has got so beautiful patterns, just like music or painting, isn't it? And we'll keep on discussing this throughout this year. Okay, let's try to solve the next question. 0.1232323 and so on. We have to express this in rational form. By the way, those who do not know what rational form is, whenever we can represent a number in this form, p by q, where q is not equal to 0 or not equal to 1, this is, when q is not equal to 0, it's a rational number. When q is 1, it becomes an integer. And so on. I think a lot of you have done this. Those who have not, don't worry, we'll do it again. First thing that we need to understand, the numbers which are repeating are 2, 3, only 2 digits are repeating. Okay, so I will write let x is equal to 0.1, 2, 3, 2, 3, 2, 3 and so on. मुझे इसको फ्रैक्शन के फॉर्म में लिखना है. कैसे करूंगा यार मैं? There's one thing which we have. देखो मैथमेटिक्स को कैसे समझना है, कैसे देखना है नंबर, that is what I'm going to teach you today with this example. Now we know that 2 3 2 3 2 3 this is what the problematic sequence is. कुछ करके हमें इसको हटाना है अपनी लाइफ से, isn't it? क्या कर सकते हैं? चलिए काम करते हैं. काश ये पूरा कैंसिल हो जाए. In some way, if this gets cancelled, our life will be sorted. How can you do that? If I multiply this by 10, 1 comes before point and rest everything which needs to be eliminated is after the point. Okay? मैं इसको खत्म करना चाहता हूं अपनी जिंदगी से. क्या करूंगा मैं? पॉइंट को और आगे बढ़ा देता हूं एक बार. Let us multiply this by 1000. 3 decimal shifts, I'll get 123.2323 and so on. Isn't it? Now my life becomes very simple. Because after the point we have similar digits and we can eliminate that. Right? So let us subtract 1000x minus 10x. इसमें से माइनस कर दिया is equal to 122. खत्म. Now there is no tension at all. 990x is equal to 122, which means x will be equal to 122 upon 900. 990. Clear? Clear to all of you? The new students, those who have this as the first class, I hope it is clear. But you know what? This is not how we have to do it. हमें तो बनना है मैथ्स का बादशाह. कैसे बनेंगे? इन चीजों को देखते ही सॉल्व कर देंगे. How? See, 0.123. Writing in the short form with a bar. I'll just put a bar over here. Is this clear? Bar is on 2 and 3. The bar is on 2 and 3. All right? The bar is on 2 and 3. Cool. So, what we have to do? Just write these numbers as they are. 123. Liख लिया. Divided by, let us write 9 for as many times as there are repeating digits. 2 digits are repeating. Let's put 2 9s over here. 99. Here. Here. And after a decimal point, only one digit has got no bar. If one digit has got no bar, let's put a 0 over here. So I'll repeat, the number of digits which have got no bar, the similar number of zeros will put over here, and the number of digits which have got bar, similar numbers of 9s we'll put over here, and then the digit which doesn't have bar, we'll subtract it in the numerator, and we'll get our answer. 122 by 990. I'll show you some more examples. This will be clear now. All right. The new students, is that clear? Okay, we'll come to that as well. That's a good question. What if there's a number before decimal? Just going over there, try to solve this question first, tell me the answer, and we'll do that. 0.12. The first step is to write this in this form, and that is how you'll be able to realize how many 9s and 0 should be there. What will be the answer now? Great. Let's write 123, subtract what is not under the bar. How many digits are repeating? Only 1, that means only 1 9 will be there. 2 are not repeating, that means 2 0 will be there, and we got our answer. Clear to all of you? By the way, how many students are watching me the very first time in their life? Becomes very simple. What if someone said, what if there's a number before decimal? 1.23. कर दे इसको, ये लो, ऐसा कर दिया. Make it complex. First time, are you able to understand? Are you comfortable with my speed, my voice, diction, and everything? 1.23 bar is only on 3, so we'll put 123. All right, we'll subtract 12, that is not under the bar. How many digits under the bar? Only 1. Let's put 1 9, and then after bar we have only one digit. That means only 1 0 will come, not 2. Is that clear now? Great. So answer is 111 upon 90. Is it clear to everyone? Point के पहले कोई नंबर है, हमें फर्क ही नहीं पड़ता, हम सब कुछ वैसे ही करेंगे. All right, बच्चे. 10, Rajut, because after decimal point there is one number, this one, which has got no bar. जहां बार नहीं है वहां पे एक 0 आ जाएगा. See in the denominator, okay, I'll tell you. देखो, डेसिमल के बाद जितने नंबर्स पे बार है, जितने डिजिट्स पे, उतने 9 आएंगे. जितने पे बार नहीं है, उतने 0 आएंगे. That's it. अजय, of course, question इस फॉर्म में नहीं आएगा. This will be a part of, small part of a big question. Okay, Ajay. ठीक. Now all of you got it. Okay. Now the next thing is prime numbers. So we'll touch all the concepts of numbers, even if they have got very least importance in MBA and friends. Non-repeating decimal numbers. तेजा कुछ नहीं होता, point की बात है ना. Point के बाद जितने digits हैं, उतने 0 आ जाएंगे. That is simple. Anurag, we can do that as well. But shortcut to ये. Okay. Coming to prime numbers. What are prime numbers? Who will care to explain? Prime numbers को कौन define करेगा? Kushal, thank you for that. Who is going to define prime numbers? Neha says prime numbers have only 2 factors. Only 2 factors, okay. Kanika says 2 distinct factors. Divide by 1 and the number itself. A lot of people think that a number which is divisible by 1 and itself is a prime number, right? A lot of you think that way, but I tell you what, that's a wrong definition. तुम बोलोगे पूरी जिंदगी क्या मजाक थी? क्योंकि if that is the right definition, then 1 would also be a prime number, isn't it? 1 is divisible by 1 and itself. अब उसकी गलती नहीं है ना कि खुद ही 1 है तो. Isn't it? तो वो बात हो गई कि शाहरुख खान वो है जिसको सब पसंद करते हैं, वो भी खुद को पसंद करता है. तो वन इज दैट आई एम नॉट कंपोजिट, तो हमें एक और स्टूडेंट बोलना पड़ रहा है. सो व्हाटएवर वी हैव डन, व्हाटएवर वी फील दैट प्राइम नंबर्स आर, उसको प्रूव करने के लिए हमें ये भी बोलना पड़ेगा कि वन इज एन एक्सेप्शन. दैट रितिका इज सेइंग. रितिका छोड़ते हैं, लेट्स मेक इट सिंपल. जो चीजें बिना एक्सेप्शन को यूज किए हो सकती हैं उनको वैसे कर लेते हैं. सो प्राइम नंबर्स आर दोज नंबर्स, देखो, व्हिच हैव ओनली, वेरी इंपॉर्टेंट, ओनली 2 distinct factors. That's it. That is the complete definition of a prime number. This is the complete definition of a prime number. Only 2 distinct factors. 1 बोलने की जरूरत ही नहीं है, itself बोलने की जरूरत ही नहीं है. ठीक है, क्योंकि वो तो कॉमन सेंस की बात है. Yeah, okay, Priti. Right. So we don't have to, explicitly mention 1 in itself, because if some number has only 2 distinct factors, it is obvious that 1 and itself will be a factor. Is that clear, everyone? That's the only complete comprehensive definition of prime number. By the way, prime numbers have got certain properties. We'll discuss that. The property is all the prime numbers. So I will represent prime numbers by P. All the prime numbers that are greater than 3 can be represented in 6k plus minus 1 form. Clear? But the reverse is not true. The reverse is not true. For example, all roses are flowers, but all flowers are not roses. Make sense? So let us try to verify this one. That reverse is not true. So if I put k as 1, what happens? 6k plus minus 1, 6 into 1 is 6. 5 and 7 is what we get when I put k as 1, right? When I put k as 2, what do I get? 6 2 is 12, minus 1 is 11, plus 1 is 13. If I put k as 3, 6 is 18, minus 1 is 17, plus 1 is 19. If I put k as 4, I get 23, 25, and there I got stuck. 25 is not a prime number, but it is in the form 6k plus minus 1. Clear? So reverse is not true. By the way, that's very obvious. What is not obvious is that, okay, listen to me carefully. 6k plus minus 1, 6k से एक कम और एक ज़्यादा, 1 more than and 1 less than 6, that means these two numbers will be 2 steps apart, yes or no? Can we say that? 6k minus 1 and 6k plus 1 are 2 steps apart, right? This is clear, but it's not obvious. Can I say that there's a high probability that 2 primes will be 2 steps apart? Can we say that? Can we say that? वो प्राइम वो तो होगा ही, ऑफ कोर्स, कि प्राइम की बात करें ना, वाह विदेशी, राइट? सो no, Ria, no, not always. That's why I said high probability. I did not say, full probability. I said there's a high probability. Okay, probable, yeah, that's probable. There's a high probability that I checked 4 cases, I got 3 cases which are like this. Hannah. All right. So the primes which are 2 steps apart, we call them twin primes. Note this down. Twin primes. Clear? So horizontally the gap is of 2 units. Twin prime. And I can say there's also probability that 2 prime numbers are 6 steps apart. Yes or no? Because 6k plus minus 1 is there. Is that clear? Plus minus 1 से 2 step आए और 6k से हमारे पास 6 steps आए. Tanish, twin primes are those primes which are 2 steps apart. Clear? Nothing here is always. It's just a probability. So there is a possibility that 2 primes are 6 steps apart. These primes are known as sexy primes. Clear? So whenever mathematicians try to find the prime numbers, the moment they get one prime, they check the other at 2 steps gap, and they check the third one at 6 steps gap. That is very common. The name is actually sexy primes. I have not made it up. I'll tell you why. See, in Latin, sex denotes 6. So we have words like sexagenarian. Sexagenarian. जो 60 साल के ऊपर 60 में चला गया. Right? We have a sextant, a chord made by 6 notes. Cool. 3 and 5, they are twin primes. Okay. I hope this is all clear to everyone. All right. Now you got the idea. Sexagenarian, sextant, there are a lot of such words derived from Latin. So we have gone through 2 different properties. Now let us talk about one more property. How to find when some number is prime or not. How to identify whether the number is prime or not. So for example, I took 101. 101 is prime or not. So with example, you'll be able to understand it clearly. 101. We have to find a perfect square which is less than 101, but nearest to it, which is 100, right? Which is 100. A perfect square, less than and nearest to it. The square root of 100 is 10. So we will check the divisibility of 101 by all the primes which are less than 10. That is 2, 3, 5, and 7. So if this number is not divisible by any of them, it's a prime number. All right. A lot of you know it, so it has been revised. Those who do not know it or forgot, now it is clear to all of you. Clear, everyone? 2, 3, 5, 7. Let's check, and we'll get to know that it is a prime number. It is not divisible by any of these 4 numbers. This is primality test. By example, this is what I have written in front of you. Let us write the exact statement. So see what is going to happen. Let's say we have a number n, any number n. Okay, any number n. Its factors from 1 to root n will be equal to its factors from root n to n. Does it make sense? I'll give you one example. Gunjan check with 101, not 10, because we have to identify 101 as a number, not 10. Okay, मैंने क्या बोला? If we have a number n, then the number of factors from 1 to root n will be equal from root n to n. Is that clear? Let us take an example. चलो ठीक है, सबको समझ में आ रहा है? नहीं आ रहा तो example ले लेते हैं. So let me take a number 60. Okay, I mean number 60. 60 के मेरे को factors देखने हैं. Okay, the first factor of 60 is 1, right? Needless to say that. Then we have 2, 3, 4, 5, 6. The next is 10. The next is 10. 10 में यहाँ लिखता हूँ reverse में. 10. Then we have 12, 15, 20, 30, and 60. Isn't it? Is that right? 60 is a number. I took a number 60. And I'm trying to prove this, that number of factors from 1 to root n will be equal to number of factors from root n to n. Bharat, I can assume 3-digit number. The problem is, I have got to write. You want me to do that? I can take 7-digit number as well. I don't mind. But you start minding then. Okay, I'll do that as well. Don't worry. So, now the thing is, the largest and the smallest and largest number, if I put a root of multiplication over here, 1 into 60 is equal to 60. Badashi, Mazaya, 2 into 30 is 60 again. See, all of them, the product is 60 only. That is the number itself. By the way, this is Piyush. I think you are Piyush. Piyush will come to that. Wait. Hold your horses. आएंगे वहाँ पे भी. Okay, so the square root of 60 is how much? We don't really know. But there's one thing we know, that it lies between 7 to 8. Yes or no? 7 7s are 49, 8 8s are 64. Okay. 7, अब देखो, सब लोग देखेंगे. The numbers, the factors on the left hand side are less than 7 and these are greater than 7, right? So this thing has been observed now. Now by using this, by looking at this, I think you might be able to relate to a lot of things that you didn't when you were kids. Let us take a perfect square. As Piyush, you want to take 3-digit number. अगर तुम सोच रहे हो 3-digit number में लूंगा और मैं कंफ्यूज हो जाऊंगा, तो ऐसा नहीं होगा. ठीक है, ले लेता हूं मैं. Okay, let's take a number. Let us take more than 3-digit number. What do you say? Let's take, but I want to show you something with a perfect square. For example, let's take 144. This is nothing but 12 plus square. I'm writing all the factors. 1, 2. I'll write first and last. 1 into 144. 2 multiplied by 72. 3 multiplied by 48. Am I right? 3 4s are 12. Perfect. 4 multiplied by 4 3s are 12. 4 6 are 24. Into 36. 5 नहीं होगा. 6. Yes. 6 multiplied by 24. All right. 7 8 8 से होगा क्या? Yes. 8 into 18 is 144. 9 से होगा क्या? 9 into 16. 10 से होगा क्या? नहीं होगा. 12 से होगा. 12 into 12. Now, there's one more thing which you need to observe. That in the left hand side, the numbers are increasing. In left hand, right hand side, the numbers are decreasing. And at the last pair that we get is of the middle factors. So, यहाँ भी वही होगा जो पहले बोला गया था. 1 to root n. So 1 to root 144 में जितने factors हैं उतने ही factor root 144 to 144 में हैं. The thing is, root 144 is a perfect square. That is why the last pair has got identical numbers. Is that clear? So what I said, 1 to root n, जो factors हैं, it will be equal to factors from root n to n. All right. एक चीज और समझनी पड़ेगी हमें यहाँ पे. When I took 60 as the example, there were 12 different factors. But when I took 144 as the example, we have how many? 15 different factors. देखिए आखिरी वाला तो सेम ही है. इससे हमें क्या सीख मिलती है? I'm repeating. How many factors did we have? How many factors of 60 did we have? How many factors of 60 did we have? 12, exactly. We had 12 factors, that is why we could make 6 pairs, yes or no? 6 pairs, one say 1 into 60, 2 into 30 and so on. Cool. And for 144, we had 15 different factors. So the number of pairs that we could make, 7 pairs were distinct, but the last one was similar. So there will be 8 pairs now, out of which the first 7 will be distinct and the last one will be similar. Is that clear? So there can be a question, in how many ways can 144 be represented as a product of 2 numbers? The answer is 8. But if they ask, in how many ways can 144 be represented as a product of 2 distinct numbers? The answer will be 7 only. Sonag, exactly. Sonag is totally connecting to the flow of the class. We started with prime and we are moving towards prime again. Cool enough? Understood, all of you? But what's not so obvious is the fact that in case of a perfect square, we will get odd number of factors. But in the case of a non-perfect square, we will get even number of factors. Nakshatra will come to that while explaining algebra, don't worry. Is that clear? Note it down somewhere. Perfect squares have odd number of factors. Even the reverse is true here. किसी भी नंबर के odd number of factors होंगे तो perfect square ही होगा, कुछ और हो ही नहीं सकता. Is that clear? Perfect squares have odd number of factors. Non-perfect squares have even number of factors. Cool. And that is why, and that is the reason when I was talking about prime numbers, रूट एन से नीचे क्यों चेक करते हैं? नाउ इट इज क्लियर टू ऑल ऑफ यू. Within prime numbers, I'm just erasing this all. In case of prime numbers, 1 to root p and root p to p, there will be only one common factor. यहाँ पे 1 और यहाँ पे खुद p, isn't it? So prime numbers are only two distinct factors. Cool enough? समझ गए? देखो मैं सिखा रहा था प्राइम और तुम सीख गए फैक्टर्स और कॉम्पोजिट भी. This is how mathematics is, you know, kind of enjoyable, and it opened doors to a lot of different things. You know, I can keep on talking about prime numbers throughout my life, and maybe 7 next slides, still there'll be more to it. But for CAT, this is sufficient. So now we'll go to the question. Is that clear? Here comes the first question on prime. Bhaskar, it's a numbers marathon. It's a revision of entire number system, entire theory of numbers. Here you have the first question on prime. Try to solve it. I'm giving you 3 minutes for this. Okay, so I can see a lot of people have marked 24, and some have marked more than 1, और more than 1 में लोगों ने 24 and 48 बोल दिया, किसी ने बोल दिया तीनों सही हैं. You know what? When I put this question, I knew that people have this, you know, feeling of competition, which is a great feeling, but at times it can kill you. 24 is the wrong answer over here. The answer is more than one of the above. The thing is, the people who got 24, they should realize that 6 itself is a factor of 24. 24 से कोई चीज अगर डिवाइड होगी तो 6 से तो होगी ही ना, तो 48 नहीं है. कुछ लोगों ने 48 निकाल के उनका आंसर सही हो गया, बट लॉजिक गलत था. द आंसर इज 6 and 24. If you got 24, 6 should already be there. Okay, this happens in CAT. I know, Aditya. Okay, let us put the values greater than 3. How do we do it? अनुराग बोलो ने B बोला है, ऊपर चेक करो. So there are multiple ways. I think a lot of you must have done. पहले 5 put किया. Let's take 5. 5 square minus 1 is 24 itself. Then put 7. 7 square minus 1 is 48. लोगों 24 मार्क कर दिया कुछ लोगों ने, बट लोगों ने कुछ ने कहा 24 तो इसको भी कर रहा है. Let's take 11 square minus 1. If you take this, you get 120. 24 का multiple है. Okay, cool. Exactly, Vijay. Cool. That's what I wanted to hear. As I said in the earlier slide, that all the prime numbers can be represented 6k plus minus 1 form. अगर ये प्राइम है तो इस फॉर्म को तो ये accommodate करेगा ही करेगा. Very good. Those who put 6k plus minus 1, that's the perfect way. So 6k plus minus 1 in place of p whole square minus 1 is what we have to calculate. Right? थर्टी सिक्स के स्क्वायर इफ आई एक्सपैंड दिस प्लस माइनस 1 है तो उससे फर्क पड़ेगा नहीं हमें. ठीक है. So we'll get plus or minus 12k and we have plus 1. Bracket की बाहर we have minus 1. This gets cancelled. So all we have is 36k square plus minus 12k. Now what I can do, I can take 12k common and I have 3k plus minus 1. All right? Understood? Equation solve किया, ये आ गया. All right? ठीक है ना. k of 1 2 कुछ भी पुट कर दो. जो पहला नंबर आएगा it will always be even for sure. First 24 then is 48. So when you put k as 1 you get 24. When you put k as 2 you'll get this will always be a multiple of 12k. Is that right? And the moment you put k as 1 you'll get 24. Whatever you keep on doing 24 का multiple हमेशा ही आएगा. 24 is correct. 6 is also correct because 6 is the factor of 24 already. We'll go with option 4. Harsh, even if k is odd doesn't really matter. That is the best thing. No, even if you take k as odd, this will be even number. Chalo, let us go to the next one. For how many numbers n that lie in the range from 2 to 100 is factorial n minus 1 divisible by n? Venkata, why not 48? Because when I think I Quanta just mentioned that if you take prime 5, it will 24. 48 तो होगा ही नहीं ना. 148. Okay, I'll explain that again. If you put k as 1, you'll get 12 into what you get? 12 into 2 or 12 into 4. 24 or 48. जो 48 से है वो 24 से तो है ही है, but जो 24 से है वो 48 से नहीं है, isn't it? Kanishka. The multiples of 48 are divisible by 24, but the multiples of 24 are not divisible by 48. Can we say that? The odd multiples of 24. The odd multiples of 24 are not divisible by 48. For example, 24 multiplied by 3 is 72. 72 is not divisible by 48. Right? Okay, this question. People have mentioned their answer is 24 or 25. Let's wait for some time and let's see which one is correct. Those who are marking, tell me the logic. How have you come to 24 or 26 or 74 or whatever? Ritik says 4 is exception. Okay, Ritik. Wait. What else? By the way, you can do it through induction as well, like putting in numbers. With induction, by putting different numbers. So we have factorial n minus 1 and we have n. So if I put n as 2, I'll get factorial 1. That is 1 only. If I put n as 3, I get factorial 2, that is 2 only. If I put n as 4, I'll get factorial 3, that is 6. If I put n as 5, I'll get factorial 4, that is 24. If I put n as 6, I'll get factorial 5, that is 120. Okay. Okay. तो मैं एक बात बताऊं तुम लोग ना अपने आप को कोसोगे सुनने के बाद. सोनक अभी ठीक है, सोनक look at this. अपने आप कोसोगे जिसने 24 या 25 बोला है. 24 या 25 आंसर तब होता जब मैं लिखता यहां पे नॉट डिविजिबल बाय n. Here I've done divisible by n. This is what happens when you don't read the question carefully. Even after knowing the concept, you'll mark it wrong. Okay. नहीं विदुषी जहर की जरूरत अभी नहीं है. अभी तो अमृत की जरूरत है. पहली बात तो ये 24 या 25 तब होता जब नॉट होता डिविजिबल. 24 या 25 देखते हैं उसके बाद. So basically we want this one thing. You know what? When factorial, I'll tell you something. This is a mind bender question. There's a reason why I said it's mind bender. This is the reason. A Barshami, I'm speaking English only. In Hindi I crack some jokes. Okay. So well, see, whenever factorial of n minus 1 is not divisible by n, then n is either prime or 4. So 4 is a number. 4 is a number which behaves like prime in this case. Understood? Clear? This is known as Wilson's theorem. Note it down somewhere. There's more to Wilson's theorem. We'll come across in this class itself, but note this down first of all. Factorial n minus 1 is not divisible by n when n is a prime number. Chintan will go to that आज ही class है, but पहले इतना लिख लो आप. All right. Yeah, I'm repeating. See, look at this. We have examples over here. Tell me something. Is factorial 1 divisible by 2? It's not divisible. Is factorial 2 divisible by 3? It's not divisible. 2 is also prime, 3 is also prime. Is factorial 3 divisible by 4? No. But 4 is not prime. Alright. Is factorial 4 divisible by 5? No. 5 is prime. Is factorial 5 divisible by 6? Yes. Yes. 6 is not prime. If I go further, 7, and here we have factorial 6, it's not divisible because 7 is prime. If I go to 8, it will be divisible. 8 is not prime. By the way, why is it happening? Why is it happening? I'll tell you that. Okay? Why is it happening? Ani, you are saying no. About what? Not clear. No. Okay, I'm explaining that. See, why? एक बात तो clear है that for the composite numbers except for this is getting divisible. Why is it happening? Let us understand that. So if I take, Abhishek, okay. अच्छा factorial clear नहीं है. Oh, all right. No problem. See, whenever we say factorial n, this means product of all the natural numbers starting from 1 till n. That is what factorial means. Vidushi, exactly, Chintan. This is what factorial means. So when I say 5 factorial 5, this is nothing but 1 into 2 into 3 into 4 into 5, which is equal to 120. Clear? So going back to that formula, that theorem, factorial of n minus 1 की divisibility हमें n से check करनी है. So when n is 6, factorial n minus 1 is factorial 5. It is getting divisible. Why? Because 6 is nothing but 2 multiplied by 3. Clear? So all the composite numbers are basically product of different prime numbers. ठीक है ना? 2 into 3 6. जैसे ही मैं यहाँ लेता हूँ factorial 6, this 1 into 2 into 3 into 4 into 5 into 6. This is not divisible by 7. Why? 7 is a prime number, but why it is happening? Because 7 तो यहाँ पे अभी तक आया नहीं ना. 7 की कोई factor नहीं है. Is that clear, everyone? Why this theorem is working for primes? Because 7 in itself is a prime number, and 7 has got no factors under 7 except 1. That is why this will never be divisible by 7. Clear? It's simple reason. There's no rocket science over here. 7 तो अभी तक आया ही नहीं. Similarly, factorial 10 will never be divisible by 11. Why? The reason is simple, because 11 is a prime number. 1 से 10 तक कोई ऐसा है ही नहीं factor 11 बन जाए. Is that clear, everyone? Now is it clear? Pay attention, focus, absorb the information. It's very simple. अगर मैं 1 से लेके 12 तक गिनती लिखूं, from 1 to 12, 13 will not be there. So of course factorial 12 will not be divisible by 13. As simple as that. Cool. Clear to all of you. Perfect. By the way, so if I ask not divisible, then it will be all primes and 4. And below 125 primes, so there are 26 numbers, 26 different numbers which cannot divide this. The answer over here is how much? 99 minus 26, that is 73. Why 99? Because the numbers are from 2, not from 1. Cool. So see, in this question there are a lot of opportunities to commit mistake, even after understanding. People might write this, you know. Oh, मैंने कुछ गलत लिख दिया क्या? This 25. Wait. Okay. मैं सही तो लिखा है. Cool. Okay, I'm repeating again. See, all the primes under 100 will be there, which will not divided, and 4 will also not divided. Right? हाँ सही था. ठीक है. All the primes plus 4. So how many primes do we have? 25 primes, and one number is 4. So 26 numbers are those which cannot divide this. The remaining ones can divide this. The question asks about divisible. So the answer is 99 minus 26. That is 73. So people can do it wrong in different ways. Even after knowing, you can do it wrong, and even after doing everything correct, people might have subtracted this from 100, which is again wrong. The answer is 73. Clear? Okay. चलो ठीक है. By the way, have you noted down the Wilson theorem? Yes or no? Wilson's theorem लिख लिया. Coming to the next one. One more question. For how many prime numbers For how many prime subtraction wrong करता हूँ wrong. ये fifth level of mistake हो जाएगी. For how many prime numbers p would p plus 2 and p plus 4 also be prime numbers? चिंतन कोई बात नहीं, ये तो नोट करने की जरूरत नहीं है, तो समझने की जरूरत है. For how many prime numbers p would p plus 2 and p plus 4 also be prime numbers? Kavya says 1, Tanish says 1, Chintan says 0. So, we discussed about twin primes, right? As you can see, p plus 2 and p plus 4 are twin primes, isn't it? And even p and p plus 2 are twin primes. So this question is a concept builder. Any two prime numbers, the minimum distance can be 2, and only two prime numbers can be there, except there's only one exception, 3, 5, 7. This is the only case where we get 3 twin primes. All right, 3, 5, and 7. Whereas in all the cases, you'll never be able to get 3 continuous twin primes. So the value of p is nothing but 3. The answer is 1. For how many prime numbers? Only one prime number, that is 3. Clear? Yeah, Vidushi, the statement is there's only one condition in which you will get three consecutive twin primes, that is 3, 5, and 7. Nothing else. So there's not even a question, there's basically a concept builder. What I discussed, I just tried to revise it through this question. Okay, coming to next one. Oh, who are they? What do you see on the board? They look so shocked or so doped, I don't know. Romeo and Juliet? All right, they are Romeo and Juliet. So मुझे नींद तो चली जाएगी ना, ऐसा तो होता ही है, प्यार में नींद कहाँ आती है, भूख भी नहीं लगती. राधा सिंह भाई बहन लग रहे हैं. Okay, all right. हो क्या रहा है? Topic is prime factorization. Okay, चलो एक काम करते हैं. A lot of people who are not like mathematics, बोले यार कहानी अच्छी है ना, रील देख लेते हैं मजा आता है, ये सब अच्छा होता है. Prime factorization, तो मैंने सोचा कि एक काम करते हैं, let us do something. Let us involve some kind of fancy stories in mathematics. So Romeo and Juliet, they are, you know that, right? This is basically they were star-crossed lovers, isn't it? Star-crossed lovers मिल नहीं पाए. By the way, all the best love stories are tragic. Lovers die, they cannot meet. Well, let us study that mathematically. Why Romeo could not meet Juliet? The reason was he was very poor. Okay, so let's say there is a wall. There is a wall of poverty, in between them. There is a wall of culture in between them. All right. There is again a wall between them of क्या हो सकता है? Poverty, culture, something else. Society, social foundations, है ना? इंडिया में होता तो जात पात भी लगाए थे थोड़ा सा. Okay. So now the problem is Juliet wants Romeo to come and meet her, but Romeo says there are 3 walls. 3 walls are there. What to do? Then Romeo asks his friend, try to break in these walls. So he says that in the wall of poverty there were 2 holes. You can cross them and reach wall of culture. And in the culture there were 3 more holes. To cross to them in society there were 1, 2, 3 holes. So now the question is, in how many different ways can Romeo choose to meet Juliet? How many different ways can Romeo choose to meet Juliet? Yeah. रहा उस टाइम जूलियट निकलना बाहर मना था, बहुत अमीर घर की थी ना, राजकुमारी थी, बाहर पहरेदार थे. Okay, so Romeo can choose 2 different ways. He can go here or he can go here. The moment he comes out of this hole, either of these holes, now he has 3 different options. 3 for the first hole, 3 more for the second hole. 1, 2, and 3. The moment he comes out from these holes, he has 3 more options for each of the holes. Yes or no? Is that clear? So Romeo has, is it clear everyone? Romeo has 2 choices in the first wall. For every choice, there are 3 choices here. So overall, he has 2 multiplied by 3 choices. And then 3 more here. 3, right? So multiplied by 3 choices again. Overall, Romeo can meet Juliet in 18 different ways. There is a motivational story. Even if the entire society wants you to not achieve something, still, if you look at this carefully, you'll always find a way. There is a will, there is a way, isn't it? Joy, we won't go to P and C. Okay? So, let's say all of you are Romeos and Juliet is the CAT exam. There's so many different ways, out of which one way is this class. So we have 18 different ways. Why give this example? Because this is how we count the number of ways whenever we have to find the number of when we find calculations. ठीक है, अब ये करने के बाद हमें कुछ समझना पड़ेगा. Is that clear everyone? No problem at all. It's clear to everyone. ठीक है, यही बात मैं मैथमेटिक्स पढ़ा रहा था, सब लोग बोल रहे थे, अब सबको मजा आ गया. चलो अब करते हैं. So now let us consider a number 60. Let's consider number 60. So first of all, I want to write it in its prime factorized form. All right, you must have done it as kids. 60. Let's pick the first prime, that is 2. 2 30s are 60. Again, 2 15s are 30. 3 5s are 15. 5 1s are 5. Overall, 60 can be written as 2 into 2 into 3 into 5. 2 into 2 is nothing but 2 square into 3 to the power 1 into 5 to the power 1. All right. So we have written this in prime factorized form. Okay. We wrote this in prime factorized form. Now I'll ask you some questions. Tell me something. Once we have written this in prime factorized form, what is the maximum power of 2 that can divide 60? What is the maximum power of 2 that can divide 60? What is the answer? What is the maximum power of 2 that can divide 60? Astha, it should be 2, not 3. Okay. 2 is the maximum power of 2 that can divide 60, of course. And what is the minimum power? What's the minimum power? So now Romeo has 3 walls made of 2, 3 and 5. And how many holes are possible? The minimum power is 0. 2 to the power 0, 2 to the power 1, 2 to the power 2. Here, these are the choices. Okay. Right. So here we have 3, here we have 2, here we have 2 choices. Overall, 3 2s are 6 to 12. Romeo has 12 different ways, which are nothing but 12 different factors of 60. Clear? Understood everyone? सब लोग पूछते हैं. The formula is that we add 1 to the power then multiply. Why we add 1? Because 0 is the minimum power which people tend to forget. Now we got it. Understood everyone? Why we add 1? Understood. You'll never forget this. Okay. So let us try to create the formula. If we have a number n which can be written in its prime factorized form as p to the power a multiplied by q to the power b multiplied by r to the power c and so on, then the number of factors, let me call them NOF, number of factors, will be a plus 1 multiplied by b plus 1 multiplied by c plus 1 multiplied by whatever we have, right? All the powers should be added with 1 and then multiplied. Cool. Why we add 1? Because 0 is also a power. So if you guys understood this clearly, put it in the comments or give some smiley or whatever and we'll move forward. Great. चलो, let us try to solve this question. मुझे पता है तुम तुरंत कर दोगे इसको 3 से 5 सेकंड में. I think we did this earlier as well for 60. I did that even for 144. You can, keep on writing it like this, like all the normal people in this world, or you can just try to be smart and calculate the number of factors. This is 2 cube into 3 to the power 1 into 5 to the power 1. Number of factors is nothing but, let's add 1 to the powers and then multiply them. 4 into 2 into 2 is 16. 16 factors are there. Number of ways will be half. That is 8, exactly. Number of ways in this written is half. 16 by 2, the answer is 8. And if it was a perfect square, then what happened? Remember that, right? They will ask you numbers or distinct numbers. 8 ways, 8 pairs are there. Perfect. Very nice. Chalo. This one. Now we have a perfect square. (144). How many factors do we have? 144 break करते हैं. 16 into 9. 2 to the power 4 into 3 square. How many factors do we have? 4 plus 1 multiplied by 2 plus 1. That comes out to be 15. Isn't it? So what is the answer? 7 or 8? 15 factors are there. How many ways will be there? There will be total 8 ways, not 7. Total 8 ways, out of which 7, total 8 pairs, ways, total 8 pairs, out of which we have 7 distinct pairs and 1 similar pair. Right? That similar pair was 12 into 12, which we did earlier as well. So someone who joined late, he was confused. What is this 7? Now you got it. Very good. Cool. Coming to next one. There's a mind bender question, mind bender 3. Riddle from investment bank in London. You have 3 to 4 minutes to solve this question. Try solving it. मजा ही आ जाएगा. देखते हैं कौन कितने लोग करते हैं. Just read the question once. 100 light bulbs are displayed in a line numbered from 1 to 100. Each light bulb is turned on and off just by pressing its switch. They are all turned off at inception. What is inception? In the beginning, right? Then 100 traders arrive. The first trader comes in and presses the switch of each light bulb from 1 to 100. Now they are all turned on, of course. The second trader comes in and presses the switch of the second light bulb, then the fourth, the sixth, and so on until 100. Therefore, turning them off since all were turned on by the previous trader. The third comes in and presses the switches of the third, sixth, and ninth, and so on up until the 100th trader presses the switch of the 100th light bulb. मतलब जो trader होगा वो वही वाला switch off करेगा, ठीक है ना? How many switches are switched on in the end? चलो, you have 3 to 5 minutes to solve this. How do you like the question? Is the question cool? Mind bender number 3. Okay, some people have cracked it already. Thanks, Harshit. Okay, so let's try to discuss this. See what is going to happen. I'll just okay. I'll take example of 1, 2, 3, 4, 5, 6 switches. Okay, so person number 1 comes. He at inception everything is what off. He first comes and makes everything on. Okay. Second one comes. So the people who are trying to count or imagine this. By the way, tell me how many of you actually tried, making the switches and writing it and filled 2 or 3 pages. You'll be confused by that. But there's one thing which we can, easily understand. Switch number 1 was touched by only first person. Can I say that? Yes or no? Switch number 2 was touched by only first and second persons. 3 was touched by first and third person. 4th was touched by first, second, and fourth person. By the way, if a switch is touched only once, it will be on. If it is touched twice, it will be off. It's touched thrice, it will be on. Basically, if a switch is touched odd number of times, it will be on, and if it is touched even number of times, it will be off. So now, if you remember that I was emphasizing on one particular thing, that was all the perfect squares have odd number of factors. I was emphasizing a lot on that. There was a reason. So my classes are like a movie of Christopher Nolan. Things are connected. They're loops, right? Non-linear storytelling in the class itself. Switches touched odd number of times, it will be on. Otherwise, it will be on, off. By the way, which switches will be touched odd number of times? The switches which have the numbers which have odd number of factors. For example, switch number 4 had odd number of factors. Switch number 1 had odd number of factors. Which numbers have odd number of factors? Only perfect squares. So from 1 to 100, we have only 10 perfect squares. 1 square, 2 square, 3 square till 10 square. The answer is simply 10. Clear? Switch number 9 was touched by first person, third person, ninth person. Switch 16 was touched by first, second, fourth, 8th, and 16th. Right? So now the people who could not solve this or would not understand this question, now they must be realizing that how beautifully can a concept be transformed into a beautiful question. Diksha says, where is given, how many touch it? It's not, it's given, Diksha. First person touches all of them, second touches every second, 4th, 6th, 8th, likha to hai. Third person touches every third switch, 3rd, 6th, 9th, 12th. Right, Diksha? Fourth one touches every 4th. Dekho, likha to hai. Second iterator comes in, presses switches off the second light bulb, then the 4th, the 6th, and so on until 100. Okay, I'll just repeat it once. The first switch will be touched by only first person, yes or no? Those who could not understand, tell me. Be with me, tell me in the comments. First switch was touched only by first person, yes or no? Yes. Second was touched by 2 people, first and second. Third was touched by 2 people, first and third. Fourth was touched by 3 people, first, second, and fourth. मतलब हर बंदा अपने ही multiples touch कर रहा है. The second person is touching the multiples of 2, 2, 4, 6, 8, and so on. The third person touching the multiples of 3, that is 3, 6, and 9, and 12. So the switches are the multiples for the people, but people are the factors for the switches. So let us replace people by factors and switches by multiples. Things will be clear. Understood? Isn't it? Yes or no? The switch number 25 will be touched by 1st, 5th, and 25th only. Whereas nobody can touch it. Replace the people with factors and the switches with multiples, and things will be crystal clear. The question creator just did that, and the question became so fabulous that it was asked in an investment bank for the placement of there was some person who was going to be an analyst. Anurag, दो लोग छुएंगे तो off होगा ना? Initially it was off. At the 0th step, in the beginning, at the inception, they were all off. First touched it, it became on. Second touched it, became off. Third touched it, became on. Fourth touched it, became off. Exactly. One is untouchable. Anurag, is that clear? So just say, touch me odd number of times, I'll remain on. Touch me even number of times, I'll remain off. Got it? Cool. Chalo, ye kar lo. Find the product of all the factors of 30,030. Sumit, that's a clever comment. Right. $30,030. Now, you can watch it, again, because we have moved on next question. एक बार जल्दी देख लेना. The timestamp will be, I think, 130. Ankit says 64 factors. Ankit, look at the question. The question asks you product of all the factors. That is what the question is. Okay. To understand this question, let us look back to what we did earlier. When I took 60, if you remember, all of you, I wrote it as the first and last factor, second and second last factor, and so on. So if you remember that clearly, I told you one very particular thing about this, that the product of all these pairs is nothing but 60. Yes or no? Right? That is right. And the number of pairs was being formed by this formula, number of factors divided by 2. Yes or no? That's right. That is right. So in this case, 60 was coming how many times? 6 times, because we could form 6 different pairs. So the formula for any number n is nothing but n raised to the power number of factors divided by 2. Is that clear? This question is a concept builder. And now I think you got it. Here, 30,030. By the way, why did I choose this number? Do you know? One of my favorite numbers. This is a number which is the product of first 6 primes. Did you notice that? The first 6 primes, 30,030 is 2 into 3 into 5 into 7 into 11 into 13. So when I was a kid, I just played with these numbers and tried to find out that what is this is very beautiful. 2, 2 into 3, 6. First of 2 primes is 6. First of 3 primes is 30. First of 4 primes is 210, and so on. Answer is, so we have powers are 1. Let's add 1 to all of them. There are 6 different values, so 2 into 2 into 2, 6 times. That is 64. Number of factors, let's put it there. Answer is 30,030 to the power 32. That is going to be our answer. Okay. There are a lot of numbers. Numbers behave in some specific way. With more classes, you will be able to realize that numbers are so beautiful. Okay, next. How many odd factors of 2880 are there? Be quick. खुशी छुट्टी कब होगी? छुट्टी क्यों चाहिए? अभी तो ऋषभ बहुत कुछ है, अभी तो रिमाइंडर्स तक पहुंचे नहीं हम. रिमाइंडर्स भी होगा ना इसके बाद. Odd number of factors. Again, this is, I don't think it's very difficult. First of all, you need to write in prime factorized form. What is its prime factorized form? I think 2 to the power 6. यही आएगा ना? Am I right? And then I think we'll have 3 to the power 2 and then 5. Am I right? Please tell me if I'm right. I'm right. Cool. How many odd factors are there? Let's forget all the even. So we'll use the formula where we add 1 to the powers and multiply only with the odd ones. Even को हम भूल जाएंगे. So here 2 plus 1 and 1 plus 1. The answer is 6. Cool. And how many even factors are there? The remaining will be even. Okay. Total number of factors over here are 7 into 3 into 2. That is 42. 42 total factors, 6 odd, and remaining 36 are even. चलो, बहुत अच्छी बात है. The next one. How many factors of 37 are multiples of 8? नक्षत्र इतनी जल्दी प्राइम्स कैसे क्या ये बताऊं? प्रैक्टिस से हो जाएगा. अच्छा रुको, चलो मैं इसमें दिखाता हूं मैंने क्या किया यहाँ पे. ठीक है, देखना चाहते हो? 2880. See. Okay, so now this Nakshatra has asked a very good question. This comes with practice, but what comes with practice? I'm going to tell you how to look at that way, right? देखना ध्यान से. 2880. When I look at this, there's certain things comes to my mind. What comes to my mind? I can see that this is 288 multiplied by 10. By the way, 288 is a very familiar number. How? Because it is nothing but double of 144. यहाँ familiar 144 तो है. तो ये देखते ही 144 दिमाग में आया, 0 आया. So 144 is familiar. Why? Because 144 is the square of 12, isn't it? And 12 is 2 square into 3. 2 square into 3, उसका square 2 to the power 4 into 3 square. So now I have this. Now I have this. And here I have one more 2. So in my mind, I did this. And then I counted number of 2's. 1 plus 4 plus 1 is 6. 2 3's and 1 5. Got it? Kopal and Nakshatra. वैसे मेरा माइंड में गया था तो अच्छी बात है. फिर अभी प्रैक्टिस अपने आप हो जाएगा. सोचना ऐसा जरूरी है, करते करते अपने आप हो जाता है. ओके. हाँ. How many factors of 3600 multiples of 8? Okay. 3600. चलो इसको ब्रेक करें. See, how do I break it? 3600. So when I look at this number, this is how I break it. 36 and 100. 100 is 10 square. That is 2 square into 5 square. Okay. 36 is 6 square. 6 is 2 into 3. So I have 2 square into 3 square. Okay, life is sorted. 2 to the power 4, 3 square and 5 square. Cool enough. 16 to 60, Joy, yeah. That's also going to look at it. Multiples of 8. What is 8? 8 is 2 cube. So basically, we have to eliminate 2 cube from here. And whatever is left, Harpreet, well done. Whatever is left, this is basically 8 multiplied by 2 to the power 1 into 3 square into 5 square, right? So these are multiples of 8. These form the multiples of 8. 8 is already here. Let's use the formula over here. Power से 1 add किया and then multiply कर दिया. 2 3 are 6, 3 are 18. 18 is the answer. Very good. Well done. Next. Factorials. Factors. Aditya, revision में हो रहा है, कुछ मस्त नए क्वेश्चन भी देखने को मिले होंगे, isn't it? Factorials, I told you earlier as well, product of first n natural numbers is what factorial n means. By the way, if you noticed, I am calling it as factorial n. I'm not calling it as n factorial. Yes or no? Did anyone notice that? आम तौर पर क्या बोलते हैं? 5 factorial, 4 factorial, 3 factorial. That is what they say. But I am saying factorial before n. Did you notice? Why am I doing it? Quant मेरी महबूबा है, मैं उसे अच्छे से जानता हूँ. Why am I doing that? I'll tell you what. See, any mathematical operator is always a suffix, and any mathematical function is always a prefix. All right. Factorial is a function, not an operator. That is the reason. The people of computer programmers are doing it. You form functions of factorial. Right? Division, addition, subtraction, multiplication is an operation. So we say mod 9. We never say 9 mod. Right, Sagar. पहले ऐसे लिखते थे. Factorial n. This is also a symbol, the ancient symbol of factorials. Okay, so this is what we have understood. Wilson theorem, we talked about it already. Well, there's one more thing which we need to understand. That if I keep on writing things, so let's say I'm writing factorial 1, this is equal to 1, factorial 2 is equal to 2, factorial 3 is equal to 6, factorial 4 is equal to 24, factorial 5 is equal to 120. So this is the first time a 0 is introduced in the end. Right? First time a 0 is introduced in the end is at factorial 5, and it will keep on happening. ये जाएगा नहीं, ठीक है? ये बुढ़ापे की तरह है, जो एक बार आता है और फिर आता ही रहता है. ओके, फैक्टोरियल 9 is 3628880, फैक्टोरियल 10 आ गया ना, जा नहीं रहा, अब और आ जाएंगे, देखना अभी 3628800. We have 2 zeros now. Okay, why is it happening? Because at 10 we get one more pair of 2 and 5. A 0 in the end, we call it trailing 0. It's called trailing 0, and trailing 0 is nothing but a multiple of 10 which is formed by a pair of 2 and 5. Alright. Good thing you'll become famous after typing this comment. 2 and 5. So now if you try to go further, let's say there's something which will happen, At factorial 5, we got introduced to first trailing 0. At factorial 10, we got 2 trailing zeros. At 15, we got 3 trailing zeros. At 20, we got 4 trailing zeros. The problem is, there's no number, no factorial, in which we have 5 trailing zeros. It will automatically be 6. Why is it happening? Because 25 itself is 5 square. Alright. We have 6 zeros over here, because 25 in itself is 5 square. We have 2 5s. And 2 to मिल जाएगा ना? See, every alternate number is a multiple of 2. But every fifth number is a multiple of 5. Alright. So if you keep on writing numbers consecutively 1, 2, 3, 4, 5, you will get every alternate number as a multiple of 2, but every fifth number multiple of 5. And we don't have to count the number of 2s here, we just can count the number of 5s and we get the answer. Exactly, Joy. 125 maybe skip होगा. Very good. That's a nice observation. 6 to 7 आएगा. Joy, not 125, 50 maybe skip हो जाएगा भाई. 25 में 6 है. In factorial 30, it will be 7 trailing zeros. Factorial 35, it will be 8 trailing zeros. Factorial 40, it will be 9 trailing zeros. Factorial 45, it will be 10 trailing zeros. In factorial 50, it will be 12. Why 12? Because 50 itself is a multiple of 25, which is the square of 5. Those who didn't get it, I'll tell you. Which one? That why 1 0 has been skipped. See, factorial 25 is what? It is nothing but 1 into 2 into 3 till 25. All right, and count number of 5s. So in this series, there is a 5, there is a 10, there is a 15, there is a 20, and there is a 25. All right, this was only 5, this was 2 into 5, this was 3 into 5, this was 4 into 5, or I can say 2 into 2 into 5, this was 5 into 5. So as you will see, 1, 5, 1, 1, 1, here we got 2 5s, and 2 5s will create 2 more zeros, 2 more 10s. All right, now have you understood this? Tushar and others? 125 पर 3 ऐड होगा, अनुराग बिल्कुल सही बात है. Is that clear, everyone? Exactly, Rimsham. Highest power of 5 होगा. So the number of tailings is nothing but highest power of 5. I hope it is clear now. Dinushi, yeah, perfect. At 50 this will happen. So if someone asks you, which factorial has got 11 number of zeros, your answer will be none. 11 0 ऐड में हो नहीं सकते. 10 के बाद सीधा 12 आ जाएगा. All right. Exciting stuff. Okay. Now, let's do something really cool. 625 factor 625 पे 4 ऐड हो जाएगा. रिमझिम कब पता चलेगा? जब वो स्क्वायर है 5 का. जो whenever it is a higher power of 5, then only. All right. Now I will tell you something. Let us do a few questions, then I'll tell you something. Let's do this one. What is the highest power of 3 that can divide factorial 20? Rimjam, is your query clear? Whenever you have a power of 5, it will be skipped. Like 25, 50, power of 5 and its multiples. Ashish, नहीं. Factorial 55 पे 11 नहीं होंगे. 13 हो जाएंगे. Okay, so how do we do that? How do we do that? Now, listen to this very carefully. Whenever you have something, this is called IGP, index of greatest power. So when 20 is divided by 3, the quotient, we are concerned only about the quotients, nothing else. We get 6, right? 6 point something, we get 6. 6 is the quotient. After that, divide this quotient by 3 again, you'll get 2. This is called successive division, I hope you know that. Keep on dividing these quotients until it becomes impossible. Right? Until it becomes impossible. Now you cannot divide 2 by 3. You won't get a quotient. You get 0 as the quotient, right? So answer is 6 plus 2, that is 8. Isn't it? This is how we do it. ऐसे ही करते हैं ना? Yes or no? Yes or no? Yes. But do you know why it happens? Sagar, limiting prime check. No. But why do we do that? Okay. Why is it happening? I'll just tell you that and you'll automatically be comfortable. See. Okay. To make you understand, I'll have to go back to my childhood and show you something which cannot be seen in normal books. Okay. See, what I wrote all the numbers from 1 to 20. Okay? Yeah, I'm explaining, Satyajit. So, what happens? I wrote all the numbers from 1 to 20. Why? Because factorial 20 is nothing but product of all these numbers. Highest power of 3. See, the moment we divide this by 3, what happens? What is the quotient? You need to understand what is the quotient. What quotient means? सब बोलेंगे T20 को 3 से divide किया, 3 6 are 18. ये है quotient, ये है divisor, ये है dividend, ये है remainder. But what does quotient means mathematically? Quotient is nothing but the numbers. I'll show you. 20 upon 3, the numbers which are extracted by the first division. the number of numbers, total numbers which are extracted are the quotient. So when divide 20 by 3, every third numbers get extracted. 3, 6, 9, 12, 15, 18. This is the third number now. Yeah, Kumar Abhishek will go there also. Okay, see, extraction, okay. First extraction has been completed. 20 by 3, 6. Now we have 3, 6, 9, 12, 15 and 18. Now the series which was there earlier, these 20 numbers, now only 6 are left. Clear? Again we divide by 3. Why we do that? You need to understand this. 3 was 3 multiplied by 1, 6 was 3 multiplied by 2, 9 was 3 multiplied by 3. Wow, one more 3 comes here. That means if I divide only once, I will be missing on this 3. 12 is 3 into 4, 15 is 3 into 5, 18 is 3 into 6. 6 in itself is multiple of 3. I missed one more 3. Now, so whenever I extract this place in a row, divide by 3 again, every third number is extracted. And every third number is nothing but another multiple of a higher power of 3. Is that clear? So 9 and 18 have what? 2 3s. And in the first extraction, we extracted only the multiples of 3. In the second one, we extracted the multiples of 9. In third, we will extract the multiples of 27. Understood? Now you know that why you do this. See, you might be knowing that this is what you do, but why you do it, the moment you get it, you won't be ever be able to forget. Cool enough. Let's do it over here in the second question. Exactly. 35 is nothing but 5 multiplied by 7. So it's very stupid if we count all the 5s and all the 7s till 100, because we know that there will be more 5s than 7s, right? And a pair will be formed only by the number which is occurring least number of times, right? Because there are a lot of 5s. Let's count 7s only. 100 divided by 7. The level of extraction, first level of extraction. 7 14s are 98. Second level of extraction. 7 2s are 14. That's all. 14 plus 2, 16. The 16 7s will be 16 pairs possible. Right, Vijay. Only check 7. Clear? Great. Next one. The highest power 24 that can divide 100, factorial 100. वहाँ पर 5 चेक करने की जरूरत ही नहीं है. Oh, why not 5? People are asking that. I told you ना 5 ज़्यादा है. अच्छा चलो मैं बताता हूँ. Vaibhav and Gunjan. Let us say that one person marries only one person and the marriages are heterosexual. Okay, so I'm giving this example because nowadays there are different limiting factors are there. So I'm assuming that one person marries only one person of the opposite gender. So in a room there are 7 guys and 5 girls. How many marriages can happen? इससे simple example हो नहीं सकता life में. How Gunjan and Sarthak, how many marriages can happen inside a room? There are 7 guys and 5 girls. Only 5. Why? Why didn't you count guys also? Harshit, why? क्योंकि जो 5 लड़कियां हैं उनको 5 लड़के तो मिल ही जाएंगे. Clear? Similarly, here we have 16 sevens, but if you count the number of 5s, you get 24 5s. 24 5s are there and 16 sevens are there. Let us say these 5s replace them by guys and replace 7s by girls. How many matches are possible? How many matches are possible? Only 16, isn't it? That is why we don't count the number of 5s over here, because they are more. Only rare is in demand. You should know that. Economics का simple rule है. Pranav, that is how people never forget. You know, these are the real life examples. Well, this question now. जॉय, क्या बात है, क्या शानदार शायरी की है. Okay. Highest power 24. यहाँ प्रॉब्लम हो सकती है. See, 24 is 2 cube multiplied by 3 to the power 1. Now they can be different problems. Now we're not sure. Should we count all the 2s or all the 3s? Exactly, Abe, Varshini. That is why I gave this example. Here we can be confused. In these cases we can be confused. So it's better to check for both. How many 2s are there? 100 upon 2. First level of extraction we got 50. Second level of extraction we got 25. Okay, we keep on doing it, right? 50 plus 25 plus 12 plus 6 plus 3 plus 1. It's equal to 97. There are 97 2s. And for 3s, 100 by 3, 33 plus 11 plus 3 plus 1. There are 48 3s. सही कैलकुलेट किया ना मैंने? 97 2s and 48 3s. Right? So what should be the answer? The problem is 2s are not being counted individually. We are counting the groups of 2 which is composed of 3 2s at once. So if we have 97 2s, how many triplets can we form? How many triplets can we form? 97 divided by 3, which is 32 point something. We can form 32 triplets. 32 times 2 cube है, 48 times 3 है, 32 कम है, answer is 32. Clear? The answer is 32. Exactly, Shubhajit. Triplet बोलते हैं, pair नहीं बोलते अगर cube हो गया तो. Gunjan is asking why divide by 8. Gunjan, the reason is simple. फिर से example दो एक. अच्छा, simple बताता हूँ मैं. Gunjan, the numbers which are divisible by 8 would be divisible by 2 for sure, but the reverse is not true. Right? So basically, if you just count number of 8s, you will get 8, 16, 24 and so on. But by the way, 1, 2 and 1, 4 can also make an 8, which won't be counted if you divide only by 8. Alright, Gunjan? Rutisha, 6 into 4 is not the prime factorized form. You'll have to write in the prime factorized form. Varshini, if you divide 100 by 3, you get 33, not 22. Alright. You want one more example? Let's take one more example. Highest power of, let me take, क्या लूँ मैं? Okay. 63. Highest power of 63 which can divide factorial 100. Let's try to do this. Rajdoot, 32 triplets आ गए 2 क्यूब के और दूसरा क्या था 3 तो 48 टाइम्स था, so 32 टाइम्स ट्रिपलेट्स थे एंड 48 टाइम्स 3 था तो 32 बन पाएंगे ना. 16 जो 3 है वो मिलेगा जी अपना पेयर. ओके राजू. Okay, let us do this one. 63, what is 63? 3 squared multiplied by 7 to the power 1. Alright, so this example will clear everything. How many 7s do we have? We had 16 7s, that is what we counted earlier as well. And how many 3s do we have? We have 48 3s. But we don't need 3, we need a pair of 3, okay, which translates into 24 pairs of 3. Is that clear? So 24 here, 16 here, which one is less? 24 by 3, 16, 7. So overall, this group can be formed by pairs of 3 and 7s. Only 16 groups can be formed. Now it is clear to everyone? Alright, clear to all? Any doubts? No? The next one. How many numbers are less than 100 are co-prime to it? People are saying 40. Euler, okay. The people who have done numbers, they know how to do it. But why is it happening? Any idea? Why is it happening? I'll tell you what. See, look at this carefully. You'll never forget. 1, 2, 3, and so on. Till 100, I wrote all the numbers. Okay, co-prime to it. That means they have got no common factor. All right. What is 100 composed of? 100 is made by 2 and 5. All right, we don't care about the powers, but I know wherever there is a 2 or there is a 5 or there are both. Okay, if there is a 2 or a 5 or both, it will never be co-prime to 100. Is that right? Is that right? That is right. Okay, now you need to understand what is happening over here. Co-prime to it. So if I subtract all the multiples of 2 and all the multiples of 5 from 100, would I get the answer? Not really. Why? Because there are some multiples which are common to both 2 and 5 which have got removed twice. So we have to bring them back. Is this part clear or not? From 100 I remove multiples of 2, then remove multiples of 5 and brought back the multiples of 2 and 5, common multiples. Why is it happening? Let us understand this through a simple Venn diagram. This is set of 2 and this is set of 5. Now, see. If I remove all the multiples of 2, these two get removed because ye bhi 2 ka multiple. If I remove all the multiples of 5, these two get removed. By the way, I wanted to remove them only once. I want to remove them only once. They have got removed twice, so I have to bring them back, and which is where this thing comes in. All right, is that clear? That is clear to all of you? Well done. But if we have a number, for example, we have 30. In this case, we might get stuck. 30 is nothing but 2 into 3 into 5. Here we need to remove multiples of 2, then remove multiples of 3, then remove multiples of 5, then bring back the multiples of 2 and 3, then bring back the multiples of 3 and 5, and then bring back the multiples of 2 and 5. But in doing so, we have brought back the multiples of 2, 3 and 5 twice, so we need to remove them as well. Now, this becomes very difficult, isn't it? कितना करेंगे? अगर 4 और कितने बचेंगे? If a number has got 5 prime factors, we'll keep on doing this. So, we need to do something which is quicker and accurate. Okay? So how do that? So 1 to 100. Again, I'll go through the method of extraction. See what is happening. The moment I remove all the multiples of 2, now what is remaining? What is remaining now? See, 100 minus 1 to 2, what is remaining now? Let's take 100 common. What is remaining now? All the multiples of 2 have been extracted, isn't it? All the multiples of 2 have been extracted, and only odd numbers are left, out of which every fifth number is a multiple of 5. Let us remove them as well, and all we have are the numbers co-prime to 100. By the way, in this case, we are not removing or bringing back the multiples of 2 and 5 both. Why? The reason is simple. Because the moment you have removed all the multiples of 2, the multiples of 10 can never be there, isn't it? You removed all the 2's, remaining are all the non-2's. So even if there is 5, 10 can never be there. Is that clear? In the previous example, we had to bring back the multiples of 10, but here we don't have to because they were not even there. Samitra, all 2's are removed. All 2's are removed. So basically all 10's are also removed. We don't have to bring them back. This is why this theorem works. So if we have a number like this, then the numbers which are co-prime to it will be nothing but 1 minus 1 by p multiplied by 1 minus 1 by q multiplied by 1 minus 1 by r and so on till wherever possible. Understood? Everyone? This is the people call it, not people, but this is called as Euler's totient function. It's not Euler, it's Euler. Okay, Euler's totient function. Totient नाम याद नहीं है तो कोई बात नहीं. But this is how we calculate the number of co-primes less than n. Cool enough. The answer is 40. Now coming to HCF or GCD. What is HCF? Highest common factor. GCD, greatest common divisor. You know that, right? 24 and 40. Let's try to calculate the highest common divisor, highest common factor. So when we were kids, that is how we did it. We will pick a prime which can divide both 24 and 40, that is 2. Remember that? Again pick a prime and divide both. 2 6 are 12, 2 10s are 20. Again pick 2, 3 and 5. Now we cannot pick any prime which can divide both. So basically whatever we have here, this becomes the part of HCF. But now even if we can pick one and we pick it, that becomes the part of, this whole becomes the part of LCM. Is that clear? So HCF is formed by common factors between both the numbers. LCM is formed by all the common factors taken once and all the uncommon factors also taken once. Understood everyone? I'm repeating. HCF of two or more numbers is the product of all the common factors taken once and LCM is the product of all the common factors and uncommon factors both taken once. Cool? No problem over there, anyone? Now, which means if we have two numbers n1 and n2 and their HCF is h and their uncommon factors, the product of their uncommon factors was a and b, then I can represent two numbers as HA and HB, isn't it? Ramu, yes, right? Is this clear? If there are two numbers, so the HCF is h, so I can write h in both of them and let a represent all the uncommon factors for n1 and b represents all the uncommon factors between in n2, then HA and HP will be the representation of these numbers. Exactly, right? Where a and b are co-primes. Needless to say, but while making a formula we need to say it. They are uncommon factors, so a and b will be co-primes, nothing common in them. A and b co-prime हो गए अपने आप ही. समझ गए सब लोग? तो फॉर्मूला पढ़ के सवाल करना गलत तरीका है, इससे आप केवल एक क्लास पास कर सकते हो, मैथमेटिक्स नहीं सीख सकते. सही तरीका ये है कि फॉर्मूला बनाओ, है ना, तो तुम पूरी जिंदगी पास कर सकते हो. Now we have done it well. So LCM of n1 and n2 will be h times ab. Why? All the common factors coming once and all the uncommon coming once again. All right. No problem there. Anyone? Let us do a few questions. What is the minimum number of cubes that can be cut from a cuboid of side 14 into 21 into 35? It's not allowed here, Sumit. ऋषभ चितमन क्या हो गया? अब थक रहे हो क्या? अरे सुमित हमें काटने हैं कुछ ना कुछ, 0 से ज्यादा. Okay. 14, 21, 35. What is the HCF? Highest common factor of 14, 21 and 35 is what? It is equal to 7, isn't it? So if I divide 14 by the highest common factor, I'll get the lowest multiple. Yes or no? Isn't it? So when I divide something by highest common factor, I get the least quotient, which is why we'll get the minimum number of cubes. Is that clear? Clear? So what is the answer? What is the answer? Venkat, Nandita. Nandita, I divided this by, see, okay, let us look at the cube now. This is 14 centimeter, this is 21, and this is 35, okay? Can you imagine this cube? Right? Yeah, I'm repeating, I'm giving you a proper, figurative approach. Okay, so, what is happening? I want to cut it in such a way that I get minimum number of cubes. If I want to maximize, I'll cut it one interval of 1 centimeter, right? I want to maximize, so, and I need cubes. What are cubes? For cubes, all 3 dimensions are equal, right? All 3 dimensions are equal. So that can be done if and only if I cut it in such a way, at such a length, which is a factor of 14, 21 and 35, all of them. So that is only 7. Divide 2 by Maya. So when I divide 14 by 7, I get a cut in such a way that I get 2 pieces. Okay? You can see 2 pieces at length of 7. Now 21, here I can cut 3 different pieces. Is that clear? Everyone? 3 different pieces. Kaise? 1 cut and second cut. Oh, यहाँ पे तो 5 cuts होंगे. At 35, we'll be having 1, 2, 3, 4, and like this. Okay? And 21, we'll have like this. Now is it clear? So all the cuts have been made at a gap of 7 centimeters. I hope all of you have understood this now. So how many cubes do we have? 2 into 3 into 5. That is 30 cubes. All right. Got the approach, everyone? So maximizing this length will minimize the number of cubes. By the way, if the question asks you what is the maximum number of cubes, in that case we can put a cut after every 1 centimeter. Right? In that case, the answer will be directly 14 multiplied by 21 multiplied by 35. That will be the maximum number of cubes of 1 centimeter unit each. Maza aa gaya? See, the thing is, the best thing about geometry and mensuration that you can actually imagine them. सामने दिखता है. When we do LRDI cubes, painting of cubes, this is going to help you a lot. Infinity तब होगा जब वहाँ पे given हो कि fractional values possible है. यहाँ मैं पहले बोल दूँगा कि that it has to be an integral side. Aratrika, of course, if there is no condition given, I'm saying when it is an integral side, तब वो होगा. Otherwise infinite हो जाएगा. Microscopic cut लगाते चले जाओ. Right, Harsh and Aratrika. Nano cuts लगाओ, nanometer पे लगाओ, autometer पे लगाओ, 10 to the power minus 1000 पे लगा दो, to keep on increasing. Okay, coming to this one. When 1062, 1134, 1182 divided by the greatest number x, the remainder in each case is y. What is the value of x minus y? Wow. Let's try to solve this one. Basically, what is happening here? What is happening that 1062 is nothing but some multiple of x and the remainder is y. Similarly, 1134 is also some multiple of x. Let it be 8th multiple, bth multiple, remainder is y in all the cases. 1182 is equal to xc plus y. Hope that makes sense, everyone? सौनक निकालना ही नहीं HCF, देखो. Is that clear? By the way, x is going to be the HCF here, isn't it? What next should be done? What can we do now? X is nothing but the HCF only. करेंगे अब. Should we start thinking about numbers and dividing them? It can take you, if you're lucky, 1 minute. If you're unlucky, it can take a lifetime. You won't be able to get the answer, right? अच्छा, Riya is saying कि HCF निकाल देंगे. कैसे निकाल दोगे HCF? क्योंकि ये तीनों तो मल्टीपल सेम के है ही नहीं. ये प्रॉब्लम है. रिमाइंडर काटना पड़ेगा उसके बाद होगा, isn't it? Here comes a very unique thing about HCFs. By the way, before solving this question, if you remember, I was saying that N1 was HA in the previous slide, N2 was HB, right? So what if I subtract N1 from N2? I get H times B minus A. Can I say something? See, understand this point. N1 is a multiple of H, N2 is a multiple of H, and the difference of N1 and N2 is also a multiple of H. Yes or no? Yes or no? Right. Right. The sum of these two numbers or the product of these two numbers will also be a multiple of HCF. But adding them will increase the number. But subtracting them will decrease the number. So let us subtract the numbers because all we want is an easy life. We can add and do it, but that will waste our time. Let us subtract and do it. Okay, you got it. Let us subtract. If I subtract this from this, what do I get? This from this, what do I get? 72. 72 is nothing but x times b minus a. I subtract this from this. What do I get now? 48. 48 is nothing but x times c minus a. Let us subtract this first and third. 1182 and 1062. What do I get now? 120. 120 is nothing but x times, oh, this is b and this is a. Is that clear, everyone? Ashish, exactly. But now you get the concept that how is it? Why this concept is working over here. Clear? Maza aaya na to? X is the HCF. So there's a common factor in these three. And now it is easy for us. What is the common factor? It is 24. So value of x becomes 24. Is that clear? Now we can calculate the HCF of 48, 72 and 120 and get 24 as the HCF, which is the value of x. Alright. Well, we got the value of x. Now we need the value of y. How to do that? How to do that? We can just divide any of these by 24 and whatever is remaining, the remainder will be the value of y. Tell me the value of y now. Nice question, isn't it? This is such a beautiful question. At the same time, this gives you insight into some very beautiful concept. Subtraction. The value of y is 6. Perfect. The answer is 24 minus 6, that is 18. Nice. The next one. The LCM of 1, 2, 3 till 50 is x. Then find the LCM of 1, 2, 3 till 55. Answer 18 है तनिष्क. X minus y निकालना था ना. Vishnu says 53x. Perfect. Very good. See, what is LCM? I told you earlier also. Product of all the common and common factors. So from 1 to 50, product of all the common and common factors is x, which means if I go from 1 to 55, then nothing much will change because beyond 50, we have 51, we have 52, we have 53, 54 and 55. The only prime number is this. This has already been covered in 3 and 17. This has been covered in 2 and 16, 2 and 26. This has been covered in 2 and 27. This in 5 and 11. But this has not been covered yet. This is standalone 53. So the answer will be 53x. Clear, everyone? Finish. There is no limit to length of the class. Great. This one. HCF of two numbers is 19. Sum is 152. Find the minimum difference between the two numbers. Minimum difference. Okay. सात बजे तक हरिओम 7 बजे I'll try to finish it off till 7. Ashish, yeah, I'll give you one mind bender question, then I'll go and have some water. Vishnu says 2. Two numbers. What can be those two numbers? Can they be 19a and 19b? Yes or no? Right? And their sum, that is 19 times a plus b is 152, which further means a plus b is 19 double aata sabko 19 8 is 152. A plus b is 8. We have to minimize this mod of a minus b as close as possible करना पड़ेगा हमें. ठीक है? So a plus b is 8. 1 plus 7 is one possibility. 2 plus 6 is not a possibility. Why? Because a and b have to be co-prime, right? 3 plus 5 is a possibility. 4 plus 4 is not a possibility. So they should be as close as possible to minimize the difference. That means 3 and 5 suits it the most. Mod of 3 minus 5, that is 2. So the answer is 19 times a minus b, that is 38. आदित्य डिवाइड देख लो 7 होगा कि 8 होगा. Okay. Sum of two positive integers x and y, their HCF is 95. चलो, this is your homework. Take a screenshot and tell me, and you will post this in the group. So because 2 and 6 were not co-prime, that's why. 2 and 6 were not co-prime. अनुराग, exactly. 3 और 5, 2 जिसने लिखा उसका ये प्रॉब्लम है. तो कई बार ना चीजें आते हुए भी गलत कर देते हैं हम लोग. आज इस क्लास में ऐसा 5-6 बार तो हो चुका है. Take a screenshot. This is your homework. Done. Tell me in the comments. Done. Take in the screenshot. Going to next one. How many numbers from 1 to 1000 leave a remainder? Leave a remainder of 3 when divided by 3, 5 or 25. Tell me the answer. What is the answer? Soumitra says 200. How, Soumitra? How can you be so quick? Good that you are quick. Gunjan, the answer is 38, 19 into 2, because 19 was the HCF, right? 19 times A minus B. इसका आंसर क्या आएगा? Soumitra has got 200. What about others? Chintan says 7. भाई इसका आंसर 0 आएगा. There is no such number. भाई ऐसा कोई नंबर हो ही नहीं सकता दुनिया में. मैंने दिमाग से खेल लिया है, पता है, बहुत तगड़ा वाला. सबका कट गया एक बार में. Remainder is always less than the divisor. Exactly, मोए मोए हो गया यहाँ पे तो. 3 से डिवाइड करके 3 से का रिमाइंडर कैसे आ सकता है भाई? 0 बन या 2 ही तो आएगा. चिराग सिंह इसलिए आंसर नहीं दिया. Okay. So I'm going to tell you, a remainder will always be less than divisor. We are moving towards remainder step by step. Now you understand. This is not just a class; it's a movie. This is called foreshadowing in literature. We'll do that in some RC class also. Foreshadowing. क्या होने वाला है पहले हल्की झलक मिल गई. Well, R is always less than D. Point number 1. Point number 2. Capital D is equal to small d multiplied by capital Q plus R. Where capital D is known as the dividend. Note this down. This is going to be the most important dividend. Most important thing today. Small d is divisor. Capital Q is the quotient. And capital R is the remainder. All right. Joel, इस क्वेश्चन का तीनों का होना चाहिए. तीनों का एक साथ होना चाहिए ना. तो 5-25 की फर्क ही नहीं पड़ा. छोड़ दो उसको. तीनों से होना चाहिए था भाई. क्वेश्चन क्या है? डिवाइड बाय 3, 5 और 25. ऑलराइट, चलो ये देखो. दिस इज इंपॉर्टेंट. नहीं यहाँ पे, अरे नहीं यहाँ पे उस और का वो मतलब नहीं है. नो, ओके, दैट्स अ नाइस क्वेश्चन. टेल यू व्हाट, दिस इज नॉट लॉजिकल. और व्हेनेवर यू क्वेश्चन लाइक दिस, और जो है वो ये दिखाता है कि तीनों से हो रहा है. इसका मतलब क्या होगा? द 3 डिफरेंट कंडीशंस, डिवाइड दिस बाय 3. सी, ओके, सी, देयर इज वन सिंगल नंबर which when divided by 3 leaves a remainder of 3, or when divided by 5 leaves a remainder of 3, or when divided by 25 leaves a remainder of 3 again. Clear? जो आप लोग बोल रहे हो एंड तब होता है जब 3 and 5 and 25 का मतलब होता है कि 3, 5 और 25 तीनों से एक साथ हो, मतलब 75 से हो. Is that clear? This is not logical or 3 different conditions. Now I hope it is clear to all of you. It's not ambiguous, not at all. वो तब होता है जब मैं इसी सवाल के 3 सब क्वेश्चंस देता. क्वेश्चन नंबर 1 which is by 3, क्वेश्चन नंबर 2 which is by 5, 3 is by 20. तब होता है ऐसा. So whenever you have a question like this, or do not feel that it is the logical OR gate. No, don't do that ever. There's going to be a big mistake. Clear now? All right. So OR was for 3 different conditions, which are simultaneously true. Cool. Now write this one: dividend, divisor, quotient, and remainder. Noted? ठीक है. अब आगे बढ़ने से पहले I want to tell certain things about remainders. I told you one thing: remainder is less than divisor. Capital D is equal to small d multiplied by Q plus R. Now, there's one more thing which I need you to understand. And I know your brain is not braining. So let's try to do something which is fun and important. Okay. Back in the childhood days, I'll take you back to the stars. Okay. So, if you remember, when you were kids, in the schools, you were told how to divide things, isn't it? अब मजा आएगा, कोई बात नहीं. ठीक है? So when someone told you, okay, divide 17 by, let's say, 7. Okay? So what was told to us? It was told, we did it in the first slide also, dividing by 7 will be that, right? Divide by 7. So we're told that if you put 7 ones are 7, 7 twos are 14, keep on doing that until you get a number which is less than 17 and nearest to it. Remember, the 7 2s are 14 and you got 3. All of you remember that, yes or no? Right? Is that right? All of you know how to divide things, yes or no? But you know, I don't know if you have done it or not. Tell me if you relate to it, because Sumitra question ऊपर लिखते थे. चलो कोई बात नहीं. You know, I was surprised that why is it only this? I asked my teacher, why not if I put 7 3s are 21 and the remainder is -4? Teacher told me, beta, remainder हमेशा positive होता है. It is something which remains. I said, yeah, makes sense. Negative numbers cannot remain. Only positive things can remain. We can count 3 things. We cannot count -4 things. Of course, remainder literally means whatever is remaining. So whatever is remaining has to be counted. I said, okay, that's nice. And I kept on believing in this. But somewhere in my mind, I felt this is also true. I'll tell you why. Because capital D is equal to small d multiplied by q plus r. If I put it here, I'll get 17 is equal to 7 into 2 plus 3, which is what taught in the school. But this equation, 17 is equal to 7 into 3 minus 4 is also satisfying. Of course, I know the remainder is what remains, and -4 is something which cannot remain. But in terms of equation, this looks correct. Yes or no? It looks correct. By the way, that's not the end. By the way, the difference between this plus 3 and this -4 plus 3, difference -4 is 7, which is nothing but the divisor itself. So we can say the positive remainder and negative remainder, if it exists anyway, anyhow, then its difference will always be equal to divisor. This is going to be our third important generalization. Right? So how many of you tried to question the society or yourself about this? Did you? If not, then no problem. Now is the time to question. It's time to understand. So what are questions I have posed to myself and to my teachers? I've come with the solutions, and now I'm sharing it with you guys. Probably we'll come to some more questions which we can share. And this is going to help you because negative remainder is a concept. It is a concept. This is going to be very much helpful to you guys. But before that, let us do this question. This is Mindbender 4. Mindbender 4. Well, 11 dacoits looted N coins from the locker of Thakur and fled towards the Chambal Valley. They decided to spend a night inside a cave as it was dark. At the midnight, one of them woke up and thought of running away with all the coins. He picked up the bag, but another dacoit woke up and asked for his share. They divided the loot in 2 parts, but 1 coin remained undivided. Soon enough, another one woke up, and upon dividing in 3, 2 coins remained undivided. This kept on happening until in the end all woke up, and 10 coins remained undivided. What is the minimum possible value of n? Is the question clear? Is the question clear? Vidushi, of course, after this question. Let's solve this question. Is the question clear? So, when 2 dacoits tried to divide in 2 equal parts, 1 coin remained undivided. They cannot divide it. So, thought of leaving with whatever they had. Third woke up, he said, okay, give me my share. So they divided in 3 equal parts, and then 2 coins remain undivided. They said, oh wow, what should be done now? So they thought of leaving those 2 coins and running away. Fourth one woke up, he said, okay, give me my share. So divided in 4 equal parts and 3 coins remain undivided. All right. When fifth one woke up, they divided in 5 equal parts, 4 coins remain undivided. So whatever number of people were, whatever number of divisions were done, 1 less than that was always remaining undivided. So in the end, when 11 divisions were done, 10 coins remained undivided. Is the question clear? You tell me what is the minimum number of coins that they must have stolen from Thakur. Clear? Question is clear, all of you? Try to solve it. People getting 121, 21, 110, 121. How many of you are not able to crack this? Then how will start? How many of you are not able to start the question at all? Not start. I told you a beautiful story about a child, who was questioning, who came up to concept of negative remainders. By the way, what if these dacoits are the divisors and whatever is remaining is the remainder? All right, dacoits, the divisor, remainders. Undivided is basically remainder. When there was one dacoit, remainder was 0, at 2 remainder was 1, at 3 remainder was 2, at 4 remainder was 3, and so on. At 10 remainder was 9, and at 11 remainder was 10. But there were 11 dacoits in total. So we have different remainders. If you have different remainders, a number of coins n will be equal to what? 2a plus 1 or 3c plus 2 or 4b plus 3 and so on. Jk, k is the 11th element, right? Yeah. 11k plus 10. So can we solve these 10 different equations? It will be very difficult to do that. But as I told you earlier, the difference between positive remainder and the negative remainder is always the divisor, which means here the positive remainders are 0, 1, 2, 3, 9. The negative remainders will be nothing but 0 minus 1, 1 minus 2, and minus 1 for all of them. Yes or no? No, the remainder is common. हर पे बराबर, no for what? इतना करेंगे तो फिर तो हल खराब सही कर ही नहीं पाएंगे. But what if we know that n is 2a minus 1? 2a minus 1. See, I'll tell you something. This is this can be minus 1 as well. So I can write it as something else, capital A. 2a minus 1, this will be 3b minus 1, 4c, minus 1, and so on. Is that clear? So minus 1 will be a better idea. Now it is clear, no? अब तो समझ में आ गया, अब तो brain चलने लगा होगा. So instead of doing it this way and wasting entire life, let us do it that way, and that is where negative remainder comes into play. मतलब क्या है कि 2 का भी मल्टीपल, 3 के भी मल्टीपल, 4 के मल्टीपल से लेके 11 तक के मल्टीपल से एक कम हमारा आंसर होना चाहिए. So we need something which is 1 less than the multiples of 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, and it has to be minimum. That means we need the LCM of 2, 3, 4 till 11 and minus 1. That is going to be the value of n. Is that clear? Clear? So this is minus 1, not plus 1. Now is it clear, guys? सोचो, अगर नेगेटिव रिमाइंडर वाली चीज हमारे पास होती ही नहीं तो हमारी जिंदगी कितनी खराब हो जाती. यस और नो? राइट? व्हाट इज द एलसीएम? आई थिंक इट इज 27570. एम आई राइट? 20 होगा. एम आई राइट? नहीं, आई एम नॉट राइट. इट विल बी 27720 minus 1. एम आई राइट? अब याद रहेगा हमेशा, ऑफ कोर्स. अब याद क्यों रहेगा? स्टोरी है ना. सी, पीपल रिमेंबर द स्टोरीज. दैट इज व्हाई दे लव लिटरेचर, दे लव सिनेमा, and they hate mathematics, but they study math just because they have to clear some goddamn exam, isn't it? But what if mathematics itself is a story, literature? Wouldn't that be exciting? Wouldn't that be the real fun? That be the real fun. Exactly. The second point is, इतना नंबर के LCM find कैसे करें? Nice question. Nice question. You are a good question. The question did not hurt me. Okay, how to find the LCM? See, I tell you something. I told you something, right? LCM is nothing but the product of all the common factors and all the uncommon factors. Yes or no? You remember that? By the way, in this, if I want to find the LCM, if I select 4, would I require selecting 2? Not really. Why? Because 4 includes 2. Isn't it? Arju? See, I am showing it to you. So let us pick the highest powers of the prime numbers which are below and equal to 11. So which all primes do we have here? We have 2, we have 3, we have 5, we have 7, and we have 11. Yes or no? What is the highest power of 2 here? 8. So if I pick only 8, I do not require picking 2 or 4. Isn't it? Right. Highest power 3 is 9. If I pick 9, I won't require picking 3 or 6 because 6 में 2 और 3 दोनों गायब हो चुके. If I pick 10, I won't require picking up. If I pick 5, I won't require picking up 10. Why? Because 2 have already been picked up. 7 is alone and 11 is alone. This is going to be the LCM. 8 into 9 into 5 into 7 into 11. Is that clear? 8 into 9 into 5 into 7 into 11. Is it clear now, everyone? So it's an easy thing to find the LCM of numbers which are successive, because we can find the highest powers easily. Shubh, because 10 was already covered. 10 had 5 and 2, so we picked up all the 2s. So 10 करने की जरूरत ही नहीं है. I'll repeat it once. All right. चलो एक काम करते हैं. गुंजन के लिए specifically. गुंजन सी. मैं 11 नहीं लिख रहा, 10 तक लिख रहा हूँ. 11 बाद में लाऊंगा. All right. Okay. See. Here. What is LCM? Product of all the common and uncommon factors. Right? What all primes do we have here? We have 2, we have 3, we have 5 and we have 7. अभी 10 तक कर रहे हैं. Okay? We want to pick up something which covers all of them. So if I pick only 2, it will cover only 2, but 4 may we have 2 2s. That will be remaining, that will not be covered completely. So is an 8. But if I pick 8 itself, which is third power of 2, then I have picked all the possible 2s in this series, yes or no? Is that right? If I pick 8, it is 2 cube, all the 2s which are possible here. अभी समझ नहीं आ रहा अगर लोगों को, तो मैं एक काम करता हूँ. Okay, see. 1, 2, 3, 4 को 2 square लिख दिया. 5, 6 is 2 into 3, 7, 8 is 2 cube, 9 is 3 square, 10 is 2 into 5. Now it looks simple. Easy to find the LCM now. Pick the highest powers of all the primes. Highest power of 2 is 3, highest power of 3 is 2, right? Highest power is 5 is 5 only. This is the LCM till 10. 11 के लिए आते हैं. 11 is only 11. Let's put 11 also here. And we got the answer. And 7, of course. This 7 is also there. Now is it clear? Now it's clear, I believe. वैसे तो सिंपल LCM का तरीका था ही जो बचपन से करते आ रहे थे, बट थोड़ा सा स्मार्ट तरीका सीख लेंगे. And this is the, I would say, the most advanced application of finding the LCM. This is 9 bender 4. Remainders are still left. अभी तो remainders का माहौल बन रहा था. हरप्रीत, दादी पैरी पाना, बीवी को पैरी पाना कहना. आज बड़ा दिन चंडीगढ़ साइन होटल जाके. ठीक है? Should we start remainders now? The remainder theorem, Stein's remainder theorem, Wilson's theorem, and all that stuff. ठीक है, आज के लिए इतना ही. एक वो कौन पूछा था मुझसे और वाला प्रॉब्लम बता दूं मैं. What was that? हाँ, 3 or 5 or 25, right? See, and there's one single number n, let it be n, divided the remainder was 3. So n will be 3a plus 3, or it will be 5b plus 3, or it will be 25c plus 3. So this number n, which when divided by 3 or 5 or 25, leaves remainder 3 in the h case. That means all this or was used for these 3 different conditions or 3 different equations, nothing else. Now it is clear. Now it is clear? Kanishka? ठीक है. So if your capacity to absorb information has gone, no Videshi, किसी एक से नहीं चलेगा. So we'll do the remainders in some other marathon. We can do that. And so by the way, you guys are tired, I know. But you must have learned a lot of things today, and a lot of stories, narratives, and there might be certain things which you'll never forget now. So I hope this is going to help you a lot. We'll do the remainders in some other marathon, and we'll start with arithmetic, algebra, etc. All right. So let's meet again, and I'm really happy to come back here to see you guys again. Thanks. Good night. मैंने कहा नहीं 3 महीने के लिए मैं ब्रेक पे था उसके पहले होते थे अब ये पहला हुआ है so basically numbers was finished and I took a marathon of doing all sorts of concepts and questions for numbers नहीं होगा ना